All right, next to last one. Still with u substitution, but now we're looking at definite integrals with u substitution, which means that we got our limits back, which means that we're now not looking for an expression, we're looking for a value, because a definite integral represents an area under a curve over a fixed interval. So a little less abstract, a little easier to check also. In fact, I don't normally do this in this format, but I plugged this in and used the second Calc 7 and went from 0 to 7, and hopefully you can see that. That's a nice reflection there. You should be able to see down at the bottom, it's 26. That's the area we're looking for. So before you even start one of these, you can pop it in the calculator and have it tell you what the answer is going to be, and then you know what you're looking for. Here's the process. We know that the thing under the radical is what we're going to let u equal. So u equals 3x plus 4. That's the same. Take the derivative of that and we get 3 dx. Solve that for dx. We get dx equals du over 3. Nothing's changed up to this point, right? We find u, then du, then dx. The difference here is that we not only have to adjust these things to be in terms of u, but these numbers here are x values, and we need those to be u values also. And it's really easy to do. I'm going to do the lower limit, and that's just going to be this, 3x plus 4, plugging in this value for x. So our lower value is going to be 4. Our upper limit, or high I tend to use, is going to be 3 times 7 plus 4, and that's going to be 3 times 7 is 21, that's going to be 25. So if we do all of the substitution, we substitute the u, we get integral square root of u. We substitute the dx is du over 3. We substitute the lower integral of 4 and the upper integral of 25. Now we have a completely different looking expression that happens to have the same value as the original expression. So bring out the 1/3. We have 1/3 the integral from 4 to 25 of u to the 1/2 power du. 1/3 u to the 1/2 gives us u to the 3/2 and then times 2/3, or divided by 3/2, and our limits are from 4 to 25. So we have 2 9ths out front, and then when we evaluate this, we put in the upper limit first, right? 25 to the 3/2 power means square root, so 5, then cubed is 125. And we put a 4 in here. The square root is 2 to the 3rd power is 8. We get 2 9ths times 125 minus 8. 125 minus 8 is 117. Twice 117 is 234 divided by 9. And I'm not going to bother doing this out, but I'm going to guess because that's what I got in the calculator. I can tell 234 is divisible by 9 because 2 plus 3 plus 4 is 9, so that's an easy test for that. I bet when you divide that by 9, you get 26. Okay, so that matches up with our prediction, with what we got out of the calculator. Let's look at another one. Sorry, there's no pause on my camera, or I would pause when I'm doing useless stuff like that. Let's look at the integral from 0 to the square root of pi of x times x squared dx. X sine of x squared dx. All right, we need to figure out what u is going to be. It's always going to be the thing inside, so in this case, x squared. Du will be 2x dx, and that's good because we've got an x out there to cancel out. Want to make sure we have that happen. Solve that for dx, so we have dx equals du over 2x. That's the same as it was for indefinite integrals. The difference here is we need to adjust our limits. So our lower limit is going to be 0 squared, which is 0. And our upper limit is going to be the square root of pi squared, which is just pi. And the reason we're squaring, right, is because u is equal to x squared. These are x values, so we want to square them to convert them to u values. Our integral from 0 to pi of x sine of, replace the x squared with u, and then replace the dx with du over 2x. That's going to give us 1/2, 0 to pi, sine u du. X's cancel, and we bring the 1/2 out in front. And I've said it before, I'll say it again. After you do the substitution and the adjustment and simplification, you should have something that's really easy to deal with. If it's not, you're not doing it right. Antiderivative of sine of u is negative cosine of u from 0 to pi. Negative cosine of pi. Remember our unit circle. Pi is over here, and cosine is the x coordinate of that point, which is -1. So we have the negative of -1 minus the negative. Right? This is the subtraction, first part minus second part. This is that negative sign. Cosine of 0 is 1, right? 0 is this angle here, cosine is the x coordinate. So we have the negative of -1 minus -1, which is 2. 1/2 of 2 is 1. So all that work for such a simple number. What you want to do is also plug that into the calculator and then do your integral from 0 to the square root of pi and check and make sure you get that same answer. No reason you should ever get one of these wrong because you're able to check them always. Next time.